Yeah, students, now we are going to see in continuation with the projectile motion that we have been seeing. So this is a range where the body is going to travel horizontally from here to here, and this is a capital H, that's the height, the maximum distance traveled, and this is already we know that's a projectile initial velocity with the angle theta, u cos theta and u sin theta. Now moving further down, we have to determine one more thing in that same sequence. It is maximum height. So maximum height we need to see. So it is just because of the vertical thing. So vertically, how much height from here till this point, what is the height which it's going to go? So distance is going to be equal to capital H. So initial velocity is going to be equal to u sin theta, because from here it is just moving up. When it goes to the highest point, what will be the velocity? The velocity will be v will be equal to e0. Final velocity is going to be equal to 0, and acceleration is going to be equal to g. Now acceleration will be, in fact it will be minus g. So v square minus u square is equal to 2gh. What is v square? That is 0. What is u square? That is, this is the value of u square. So it's going to be u sin theta, the whole square, is equal to 2 into g into h. So what is the next one? Height is equal to height is going to be equal to, now here it's, you get minus sign because g is minus. So what is height is equal to? So these two things goes down. So it's u square sin square theta upon 2g. So you get here upon 2g. This minus and this minus gets cancelled out. So this is a formula for height of the projectile. So you need to understand this. So let us totally wrap up the whole thing. So we have seen path of a projectile. What is the formula for path of the projectile? It's all should be in tips. You should definitely memorize all the formulas. So the first one is path of the projectile. I'm just trying to finally wrap up all of them. So y is equal to x tan theta minus half into gx square upon u square cos square theta. So this is the equation here. For x and x square are the terms which says it is a parabola. Second one is time of flight. So we saw capital T is equal to 2u sin theta upon g. So that's what the time of flight is. Third one is range. Capital R is equal to u square sin 2 theta upon g. Here it is sin 2 theta. That means 2 times of sin theta cos theta will be the expansion here. And next one is height. We saw the maximum height, how much it's going to be. H is going to be equal to u square sin square theta upon 2g. And we already saw the velocity, also velocity at any point. So velocity at any point is going to be under root of v y square plus vx square. That you can see it and then do it. But remember, these four formulas are always, it will be coming again and again. So this path of a projectile, time of flight, range and height, these are all the very important formulas. You should memorize all these formulas. Don't confuse them. It's quite similar. 2u sin theta, u square sin 2 theta, u square sin square theta, and this everywhere there is g and 2g. You can get quite confused with all of them. Please be careful about it, and these are all very important formulas. So we are going to see the next the last topic of the projectile, that is projection from a height. So let us see, at a height h, this body is being projected with the initial velocity of u with the angle theta here. We can immediately come to the two components. Resolution of vectors is called u cos theta, and this will be u sin theta. And this body is going to go up and come down here, finally reaching here. Now we are not going to go to the entire of the derivation. We are just going to see how much will be the height in which it is going to come down, and as well as time of flight. The first thing is, when this is going to come down from here to the dropping down, remember the time taken to go up and come down, you can easily calculate by the way in which the body can be projected from here. So the component of velocity which will be helping it to go up and come down, now just see the vertical alone. This body goes to the height and comes down. That's enough. You just calculate that way. So u sin theta is the main component of the velocity which is there. So when the body goes up, the vertical velocity is equal to u sin theta. So u sin theta goes up and the body finally is going to come down. So what will be the height in which it is going to happen? H is going to be equal to, you can say, ut plus half gt square, the same formula. H is equal to, what is the u value? U sin theta. So you can write it as minus u sin theta times of t. Why to do minus? If you do minus, because the displacement, final displacement is only height. From here it is going to come down, but this is going above with a minus negative signature, negative value. So, and the g value we can take it as a positive here. So plus half g t square. So this is the main expression you need to consider. We are not going to go beyond this one to find out finally what is the thing. Let this be here itself. Please understand, with this expression you can find out the height in which it is being dropped down. Alright. So the next one is the time of flight. Time of flight is going to be capital T. So that is the capital T here also. The same time which is going to take place for the body to from here to come down, that says the total time which is going to be the T here also. Okay. So if you want to find out the range, how to find out the range? The range of the thing is going to be equal to range is equal to which component it makes it to coincide. The component of the velocity is going to be u cos theta. So it's going to be u cos theta into time, that will time. So that's what range it is. So the height, time of flight and range. These are three things which you need to understand. Time of flight is formula is right there inside itself. If you find out other terminology, time of flight you can find out. So this expression makes it quite important, and this expression is the second expression which you should know. Alright, we'll now going to do some numericals based on these things. So there are, before going for the numericals, again the wrap up of all things, there are three kinds of projectiles. Three projectiles are there. So what are the three projectiles that we saw? First one is from a height, just shoot straight and the body comes down here with the influence of gravity. So that is u. There is no theta involved. You will not find any theta value involved. So it is straight down. That means this body is just being dropped. So remember, if a body is just dropped down, the time taken is equal to the body is projected and it comes here. Both of them will have the same time. If you drop the same ball down in this height And if you are projecting like this and the body is coming down and the influence of gravity, both the timing will be same. That makes it very, very important for us to go to the same formula how it comes. So that's the first projectile. Second projectile, it is a projectile where the body is given an angular projection. So from here the body just goes here like this. With the velocity u, it is given with the theta value. So you have u cos theta, you have u sin theta, and the body has a range and height and all these things. Second projectile. The third projectile is, just now we saw, from a height you project a ball upwards and it comes down like this. So with an angle theta. 3 projectiles are there. So this one is important, this also important, and here some of them it can come in this way also. So there are 3 variety of projectile that we have seen. Both the derivations you have seen. This one derivation is not much important, but numerically it will be coming. Okay, now let's go to the numericals now. So you can turn to page number 197. There are numericals based on projectile motion. So we'll take the first numerical, which is question number 59. A bomb is dropped on an enemy post by an aeroplane flying with a horizontal velocity of 60 km per hour at a height of 490 meters. Height is given here. In what height it is being there? The bomb is going on 60 km per hour. How far from the aeroplane must be from the enemy post at the time of dropping the bomb? Suppose if it is going to drop, how far it should start releasing so that the projectile will come and it will hit the enemy camp so that it may directly hit the target. What is the trajectory of the bomb as seen by the observer on the earth? What is seen by the person sitting inside the aeroplane? So there are 2 things which is given here. So let us try to understand the question, how to do this one. Let's first of all draw the diagram. Always in every question read slowly and draw a diagram. So we're going to do that now. So if you draw the diagram for this question, a bomb is dropped on an enemy post by an aeroplane flying horizontally with a velocity of 60 km per hour at a height of 490 meters. That's what the diagrams I have drawn for the question. How far the aeroplane must be from the enemy post? Suppose this is the enemy post. So these are the enemy post. All the enemies are tented here. How far the aeroplane should be at the time of dropping the bomb? If it drops the bomb here, one by one. Now these bombs are going to have the same velocity of 60 km per hour. The enemy is going to just keep going and dropping the bomb. This bomb will not just drop like this because it is already having a velocity of 60 km per hour. So the bomb will take a trajectory like this. The bomb will take a trajectory like this and then finally hit here. So every bomb will be going along this direction and then slowly coming down and hitting here. So we need to know what is going to be the distance here it's going to be being dropped. Few parameters are given here. You will be able to easily find out here. So the first one is the time taken to come from here to here. First one is time taken. Already we know the time taken from here to here is equal to the time taken for any body to just drop down also. So if it is that's the case, you have initial velocity 0 and then height is given here. So h is equal to ut plus half gt square, 0 plus half gt square. That is height is 490 meters and g is 9.8. It is already given there in 9.8 you need to take. So it's equal to, so how will you do it? It is 9.8 upon 2 t square is equal to 490. So this will become 4.9 t square is equal to 490. So when you do this one, you will get here, this is cut, 100 it will become. So t square is going to be equal to 100, t is going to be equal to 10 seconds. So the time taken is given here. Time taken from here to this point is given here. Now we need to find out the distance here, a range. Range you need to find out. What is the range? It is going to be equal to this distance, this speed, into the time taken from here to here. That is the time taken from here to here is equal to the time taken from here to here also. So range is equal to ux into time. What is ux? 60 kilometers per hour into time. Time is 10 seconds, right? So if you want to calculate 10 seconds in terms of hours, so it is 10 upon 60 into 60. So finally you will get here answer as 1 by 6 kilometers will be the answer. So 1 by 6 kilometers, that means 1000 upon 6 meters will be the distance here. So the question is over. Now it is already asked what will be the way in which it will be going. It will be going in a parabolic path. It will take a parabolic path. For a person who is standing here and observing, anybody standing here and observing, he will see this whole thing as a parabola. If a person is sitting here in the aeroplane and looking at this one, he will see it is just vertically drawing down. There are two motions. One person is sitting here and watching this whole thing, he will see it is just vertically coming down. The person is watching from the earth, he will see it is going in a parabola. So that is a perception of difference will be there. So we'll do some exercise questions from page number 209. You can turn to the exercise questions where based on projectile motion, there are some questions are there. We'll try to do this one. Question 22. Two bullets are fired with the horizontal velocities of 50 and 100 meters per second from two guns at a height of 19.6 meters. A. Will both the bullets strike the ground? Yes, of course it will strike the ground. So the answer is yes. Yes, it will strike the ground. If yes, after how much time and which bullet will strike first? So it is the matter of trying to find out how these bullets are going to come down. It is already fired from a height edge. So keep a look on this, how it is. So it is already fired from a height edge. So you can find out what will be the way in which it will be coming down. So there is a height. So in this height, this bullet is going to be fired. And one is coming with a 100 speed and next one is coming with a 50 speed. So the 100 speed one will go further and come down like this, and the 51 will come down like this. So there are two ranges will be there definitely. How much time and which bullet will take first? What is the time will be taken and which bullet will be there? Now remember, the time taken for any body to be dropped from here to here is equal to the same time which is going to be taken from here to here also. Similarly, the time taken from here to here also, the same time this will also take. So what time this will take, which will go first, both of them will go at the same time. There will not be any difference. Don't think 50 will come first and then this will come later because it's a bigger path. No. It is independent of those parameters. The time taken from here to here is equal to the time taken from here also. So both will come at the same time. So what is the time? That's what it is asked. How much time? So you need to again go from here to here. If you are dropping, h is equal to ut plus half gt square. What is u? When you are dropping down, u is 0 plus half g into t square. What is the height? Height is already given here as 19.6. So it is 19.6 and g value is 9.8 is given here. So put 9.8. So 19.6 is equal to half into 9.8 t square. So this will become equal to 4.9. So this will go down. So t square is going to be equal to 4, t is going to be equal to 2 seconds. So what is the answer here? So 2 seconds it is here. And what will be the path? Definitely it will be a parabolic path it will take. So it's already a parabolic path is given here. Look at the next question. Similar question. A bomb is fired horizontally with a velocity of 20 meter per second from the top of a tower of 40 meter high. After how much time will it take, and what horizontal distance from the tower will the bomb strike the ground? Same exact question. Same formula you need to use. But it is asked, what is the time taken? So how much time it will take? Same time it will be there, and then how much it will be the striking distance also it is asked. So I think you can try this question yourself. You'll be able to do this one. So if it is the same thing, if it is u is going to be equal to 20 meter per second and the height is going to be equal to 40 meters, and you are asked to find out the value here, h is equal to ut plus half gt square. So 40 equal to 0 plus half, g is 9.8 into t square, and there will be a little bigger calculation. You need to do this one and you will get the answer. Once you got the t, then range is equal to u into t. What is u? 20. T, whatever you find out, you can find out the range. That is the horizontal distance travel. What is the horizontal distance means? The range. Okay, so please do this as a homework for you. Go to the next page, page number 210. Question number 33. This is also a homework for you. A projectile is fired horizontally with a velocity of 98 meter per second from the top of a hill of 490 meters high. So it's already given there. Now we need to find out the time taken and the distance traveled from the target from the hill. So this is similar question you need to do. Now we will do the 34th question. This is a homework for you. And 34th question. A body is projected horizontally from the top of a cliff with a velocity of 9.8 meter per second. Already it is from the top. Horizontally it is being there, same instance. After what time its horizontal and vertical velocity become equal? It is asked, both the horizontal and vertical velocity is going to be equal. What is the time taken? So it is little a different question. We will try to solve this question. We'll see how we need to make this solution. So the question says, there is a height here and this body is now projected with a initial velocity of 9.8 meter per second. And after it comes maybe for a particular distance here, that particular moment we find the Vx and Vy is getting equal. Exactly it is equal. Both of them Vx is going to be equal to Vy. What is Vx? The horizontal velocity is going to be same all the time. It is going to be Ux and this is also going to be Ux. So this Vx is going to be Ux. What is the value here? It is 9.8 here. It is already, that's the way it is. Always the horizontal velocity will be remaining same. So here Vx is going to be the same 9.8 itself. That means this is also going to be 9.8 because this is 9.8, this is 9.8. Okay. Now what is the condition? What is the theta value? It will become equal here is the tan theta is going to be equal to Vy upon Vx. So when these are, both of them are equal, so when Vy equal to Vx, tan theta is going to be equal to 1. So theta is going to be equal to 45 degrees. So Vy is going to be equal to also 9.8 meter per second. It's not only Vx is 9.8, Vy also is 9.8. Right? So if Vy is 9.8, so what is the time taken? How much time it will take to finally come down? So from the top, this is going to drop down till this position, and how much time it's going to take? So Vy at this point of time, Vy is 9.8 meter per second. Initial velocity is 0. From here to here it's going to come. Time is asked. So how will you find out v is equal to u plus at? So final velocity v is going to be equal to 9.8, u is 0 plus g t. So what is g? 9.8. So 9.8 is equal to 9.8 into t. T is going to be equal to 1 second. That 1 second is already given here. 1 second is the answer here. 1 second is the answer here. So we finally bring out this final format. Same kind of question here. So we will go to the next question. Question number 24. A ball is thrown with a velocity of 15 meter per second at an angle of 30 degrees with a horizontal. There is an angle 30 degrees. So this is to be noted along horizontal. Determine the time of flight, the maximum height attained by the ball. So it is a very straight question with simple things given here. 15 meter per second and 30 degrees is given here. Time of flight is asked and maximum height has to be found out. So write on the first of all initial quantity. So the question is this: u is equal to 15 meter per second and theta is equal to 30 degrees. This is the diagram it will flow. Please always draw a diagram for every question. That is very important. So what it is asked, time is asked. Time of flight, you should know the formula now. Please remember and write the formula. You should memorize the formula all the time. 2u sine theta upon g. That's the formula. Every format is given here. U is given here 15. So it is 2 into 15 into sine 30 upon g. And here g is given here as 10. So once you do this one, 30 into 1 by 2. This is 1 by 2 upon 10. So it gets cancelled out. T is going to be equal to 1.5 seconds. Height is asked. Maximum height. What's the formula? Height is going to be equal to u square sine square theta upon 2g is the formula. So it is 15 square sine square 30 upon 2 into 10, which is 225 into 1 by 4, because 1 by 2 will be the answer. 1 by 4 into 2 into 10. So you can do the calculation. After calculation, you will find this answer is coming as 2.8 meters will come. Alright, so it's a straight question. There's nothing much twisted. Basic parameters are given, you need to substitute and get the answer. So that's the way. Now we'll go to the next question here. The question is question number 25. Look at question number 25. A stone, now 24 we did 25. A stone is thrown from the horizontal ground at an angle of projection of 30 degrees. 30 degrees is the same thing. Here also 30, here also 30. With a speed of 49 meter per second. Here it was 15, it is 49. Right? Calculate the time of flight and horizontal range. Range is asked. Another formula you have to use. Do it as a homework. This is a homework for you. Alright? Now look at the next question here. So the next question is question number 26. An arrow is thrown in air. Its time of flight is 5 seconds. Range is 200 meters. Now these two parameters is not given. The speed is not given, the angular projection is not given. They have given the answer here. They have given the time of flight, they have given the range. Determine the following. So we have the vertical component of the velocity. What is the vertical component? That is called u sine theta. The horizontal component, u cos theta, you need to find out. The maximum height, how much maximum height it will go, and then the angle made by the horizontal. So these are the things which is given here. Pretty decent to take the equation and then do it. So first of all, write the parameters now. First line, time of flight equal to 5 seconds. Second line, range equal to 200 meters. Now for both of them, you write the formula also in the nearby. So the diagram will go on like this. 200 meters is the range, u is this velocity, and it makes an angle theta here. So we are asked to find out this velocity, what is u cos theta, and this velocity, what is u sin theta. The total, what is u sin theta totally, we need to find out. So t is equal to 5 seconds it's given here. So you can write here as t is equal to 2u sine theta. So that is 5 is equal to, range is also given here, 200 meters is equal to 200 is equal to u square sine 2 theta. Expand this one, u square into 2 sine theta cos theta upon g. Now you can divide both of them. You can divide this equation number 1 and equation number 2, and get an answer out of that. So that will become quite easy for you. So 2 divided by 1. So 200 divided by 5. First of all, put this equation is equal to, put this equation in the numerator. This u square upon g into 2 sine theta cos theta divided by, this equation you need to put 2u upon g sine theta. So you get here g and g will get cancelled out. Sine theta and sine theta will get cancelled out. And you can get 2 and 2 also will get cancelled out. 1u and another u will get cancelled out. So there are quite a lot of them, it's got cancelled out. So you get here finally only u cos theta. Just u cos theta remains. That is equal to, this also if you cancel out, it is 40. So u cos theta is going to be equal to 40 meter per second. It's already the one which is required. The first part of the question is already answered here. Now we need to find out the sine theta component. So how to find the sine theta component? You have to put this one, put this value over here. So you'll get this answer. So 200 is equal to u square 2 sine theta into cos theta upon g. So here you can make it as 2u cos theta and u sine theta upon g. You can make it. Why did you make it? This one 2 is here. This u square has become 1u here, another u here. One is cos theta, another sine theta. So that's going to be 200. What is u cos theta? It is 40 here. So it is going to be 2 into 40 into u cos sine theta upon, what is the value of g? And g is already given here as 9.8. You need to take it as 9.8. So take it as 9.8 and it's equal to 200. So this entire value, this gets cancelled out, it is 100, and again this, it gets cancelled out, and you get here 98 upon 4. So u sine theta is equal to 98 upon 4. That will be finally giving you an answer as 24.5 meters. So that is u sine theta. U sine theta we got it, and u cos theta also we got it. What is the next question it is asked? It is asked as maximum height. What is the maximum height in which it will be going? So the question continues. The third part of the question, it is maximum height. Height is going to be equal to u square sine square theta upon g. So height is going to be equal to u sine theta the whole square upon g, because that's the way it becomes. So what is u sine theta? Already it is there, 24.5 the whole square upon 9.8. That is height. So if you do this one, you will get 30.6 meters you will get. So I'm not going to the entire calculation. I'm just saying the answer and writing. You can do the calculation and see how it comes. And then it is also asked the angle made. What is the angle here? What is theta value? So if you want to know the theta value, you can just do it here itself. So divide this both the equations. When you divide u sine theta upon u cos theta is going to be equal to 24.5 upon 40. So it is going to be equal to tan theta is going to be equal to 24.5 upon 40, and you can do the calculation. Theta is going to be equal to, so you will get here tan inverse of 24.5 upon 40, or otherwise you can just multiply it by 2 both sides. It is going to be then 49 upon 80 you will get. So that's the tan theta value. So all the things it has been found out. Pretty simple, quite an easy question, but it is a little lengthy. So the next question is question number 27. You can do it as a homework for you. So please read the question. It is, the cannon is fired up to 500 meters. The range is given here horizontally. What should be the angle of projection? Theta is asked. If the shell is fired with the velocity, u is given here. You can easily find out this one. 28th question and 29th question are quite similar. So I'll do one other question. Next question will be the homework for you. So this is, a stone is thrown from a bridge at an angle of theta 30 degrees down with the horizontal with a velocity of 25 meter per second. If the stone strikes the water after 2.5 seconds, then calculate the height of the bridge from the water surface. So there's the 30 degrees, there's a height is also given here. So we need to go know a little bit about what kind of diagram this will look at. So let us see this one. There's a bridge here. Maybe it's a kind of a bridge which is here going on like this. A stone is thrown from here at an angle theta, at an angle of 30 degrees. So the stone goes up and comes down like this and hits the water. And the way in which it is being thrown, it is 30 degrees is the angle here. And it is thrown with a speed of 25 meter per second. This is 25 meter per second. And as it reaches here, the entire time, the time taken is 2.5 seconds. This is only the time taken. Basic things, this is the way in which it is given. You are asked to find out the height here. So, components here, u cos theta, and this is u sin theta. The height formula, already we know, minus u sin theta into t, ut plus half gt square. This is what the formula will be. And when you are trying to substitute this one, minus u, 25 meter per second, it is 25 meter per second, it is 25. Sin theta is sin 30. Sin 30 is 1 by 2. Timing is 2.5 plus half. G is 9.8 and t square is 2.5 the whole square. Everything is given here. So it is minus here, this one is. All things are given here. You need to find out the height. Height you can just finally calculate. Okay, it will be 61.9. It is given here. You can straight away calculate this one. The next question. We'll see the next question quickly. It is, a stone is, question number 29. A stone is thrown from the top of a tower at an angle 30 degrees up with a horizontal with a velocity of 16 meter per second. After 4 seconds of the flight, it strikes the ground. Calculate the height of this one. Exactly the same question. So please do this one also. You need to do the same thing. Theta is given here and time is given here and the velocity is given here. Please do it. You will be able to get the answer. Also, the horizontal range is asked. Range is going to be equal to u, whatever you got this one. This is, if you got the timing here, so you need to find out the u sin theta, u cos theta. If you know, you can easily find out this one. Range is going to be equal to u cos theta into time. So u is already given there. It is, u is 16. Theta is given here 30 degrees. And time is already given here in the next question as 4 seconds. So you can easily find out range also. Right? So please do this question. Question number 29 is also homework for you. Right? Next question. Question number 30. 30th question. A player throws a ball at an angle of 30 degrees up with a horizontal with a velocity of 14 meter per second. If the point of projection is at a height of 12 meters from the ground, then calculate the distance up to which the ball is thrown by the player. Exactly the same way of what it is here. It is thrown from a height from 12 meters at an angle of 30 degrees with the initial velocity of 14 meter per second. The same diagram goes on here also. So the question is like this. With the initial velocity of u, it is projected, u cos theta, u sin theta, the same question, and then 12 meters the height. So u, it is already given here as 14 meter per second. Same thing which goes, height is going to be equal to minus g sin theta, minus u sin theta into t plus half g t square. How this one came? H is equal to ut plus half at square. So u is this velocity u, and this is a minus value. Now once you get this one, put the values here. T is going to be equal to 12, and this is minus, and it is 14 sine 30. Sine 30 is 1 by 2 into t plus half into g is here given as 10 t square. 12 is equal to minus 7t plus 5t square. So 5t square minus 7t minus 12 is equal to 0. Do the quadratic, you will get t here. The final value of t you will get here as 12 by 5. You will get 12 by 5 seconds, you will get the t value. Once you got the t value here, then you have to find out the range. So the range you need to find out. What is the range? Is going to be equal to u cos theta into t. T is already given here. U is already given there. Theta is you know. You can find out the value of range. So please try to find out the value of range. With that, you can finish this question. The next question here, question number 31. So the 31st question is, a projectile has a range of 50 meters, reaches a maximum height of 10 meters, calculate the angle of the projection. Range is given here, put the range formula and is equal to 50. Maximum height is given here, put the value here, and then you can calculate the angle here. So you have height formula is given here as u square sine square theta upon g, that is 10 meters. Range is 50 meters, u square sine 2 theta is 2 theta if you want to expand, 2 sine theta upon cos theta upon g. So you can divide both this one. 10 by 50 is equal to, you put this 2 value and you will be able to get everything cancelled out. Finally you will get that answer of theta you can easily find out. Try this question, I will give it as a homework for you. The last question here, find the angle of projection for which horizontal range and maximum height are equal. Try this one also. Range formula and height, you can just equate and see how it comes, then you will get the value of theta value. Alright children, with this I close. Thank you, do all the homework. Thank you so much.